Good morning, ladies and gentlemen. Hope you had fun with Sheriff Mangum. So I was going to show you one thing that I forgot to talk to you about with velocity before we start graphs, which is resultant velocity. So to do that, I'm going to switch over to my handy dandy, not that, this. Switch over to my screen, and I'll delete the stuff off of here. And so what I was going to show you is how to calculate resultant velocity. So write this down, resultant velocity, and this is just a combination of all velocities. Or it's a net velocity. Okay, so give me a second to write that down. It's a combination of all velocities or a net velocity. By the way, Miss Hill, thank you so much for watching my crazy chair runs for me. There will be some chocolate and carbonation involved in your future. Okay, so I'm going to delete that. If somebody didn't get it, you can rewind. Okay, so let's say that you are on a bus. I blame that on Addison Bauman. I think it was his fault. Or it's probably Jeremiah's fault. Bullfrog, it's your fault. Okay, let's say you're on a bus and it's going in this direction at 2 meters per second. Okay, because it's just starting off. And you were on this bus walking to the back, dink, 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 at 1 meter per second. Okay, so you're going this way and the bus is going this way. Are they working together or opposite each other? Right, they're working opposite each other. Okay, so when they work opposite each other, what do you think you'll do to these velocities to get a net velocity? If you guessed that you would subtract them, you would be correct. Okay, so when they're opposite each other, you're going to subtract. I would make sure you put that. Okay, so if we take 2 meters per second minus 1 meter per second, that gives you a meter per second towards the back. Okay, and it's going to tell you, let's say this is going east and you are going west. Okay, so this would be west. Okay, this would be 1 meters per second west. Okay, now it doesn't have to be negative because you can just take and tell which direction that it's going. Oop, it's not going to be going west though, I lied. It'll be going east because winter, winter, chicken dinner, it's going to be going this way. Okay, so hopefully I didn't mess you up too bad there. Oops. Again, that's Bullfrog's fault. Okay, all right, so let's look at another example. Let's say that there's an escalator and, wow, that looks bad, doesn't it? How about we do this? Escalator. That's better. Looks kind of like a shark. You are going up the escalator, and the escalator is also going up this way. So let's say you're going at 2 meters per second. And let's say that the elevator is going 5 meters per second. It's probably booking it, but you know. Okay, so if you're working together, you're going to, you're going to add. Okay, all right, so you would take 2 meters per second plus 5 meters per second, and that's going to give you 7 meters per second for your resultant velocity. Okay, all right, so on your sheet, make sure that you answer those questions. Make sure that you read carefully on those, and then we'll go over them tomorrow when I get there. I will also give back your graded papers tomorrow. All right, love you, bye. Not bye yet. I got to get back to my normal screen. Dink. And love you, bye.